Hello everyone. So today I am going to explain about a concept of space 3D. Space means you don't feel that space in the sense which is far away from the ground. There is no gravity. It's not like that. Space in the sense we are going to assume the concept. We are going to assume the body is in three-dimensional region. Three-dimensional region. Two axes, X and Y. But from today, we are going to consider the three axes. I mean the concept of space X, Y and Z axis. Okay. Actually, for our easiness, we understand the things in two dimension only. But in reality, everything is 3D. Some animation movies, they will give that sideline, I mean heading that it is also available in 3D. It means there are some theaters which offers three-dimensional screen, and before entering into the three-dimensional screen, you will provide it with lens. If you put that lens, if you watch the movie, you feel that the characters of the movie are you are just revolving around. If there are any gun bullets in the scene, then you feel that the bullets are hitting you. That is the 3D experience. It means in the Z-axis. 3D is nothing but Z-axis. Z-axis the space. So we are in the space. I am telling you in space. You are listening in space. But for our comfortability, we majorly concentrate on 2D. 2D in the sense that everything which have two axes, length and height. Length and height. Two dimensions means this is length and this is height. But in third dimension, it will be thickness. It is called as thickness. In the some question papers, I found questions regarding three-dimensional views, the space also. So I will tell you the concept, three-dimensional concept in a easy way. I hope that I will tell you in an easy way. I want you people to concentrate, you people to practice. Mechanics is very easy for the people who are dedicating, who are hardworking. So in this concept, the force is considered in the space. Space is the x-axis, y-axis, z-axis. So in the space concept, we consider the force in a space. Space in the sense x-axis, y-axis, z-axis. That's it. So now I will tell you the concept which is resultant of non-coplanar concurrent forces. Non-coplanar concurrent forces. In 2D, I told you that coplanar concurrent forces. Coplanar means force F1 is going right, force F2 here, force F3 here. Everything is on the same plane, on the same point. This is called concurrent coplanar forces. But in the space concept, I will discuss the concept of non-coplanar concurrent. Okay. So why it is called as non-coplanar concurrent means, so here a force F is acting, a force F is acting in this direction. Okay. So the obviously in two dimensions there are two components, 2D, two components which are Fx, Fy. But in 3D there are three components. That's it. Those may be Fx, Fy, Fz. That is the difference. Okay. So in this concept, if a force is acting in this direction, the components of the force may be, this is your Fx, this is your Fy, this is your Fz. Now the angle between the force to the horizontal component is theta x. The angle between the force and the vertical component is theta y. The angle between the force and the third component, z component, is theta z. So here it will be given that all the angles which are making between the force which is to be converted into its components to the respective axis. The angle made by the force with x-axis is theta x. The angle made by the force with y-axis is theta y. The angle made by the force with the z-axis is theta z. That is the logic. Okay. Force F is acting in space. So now come to the components. Component Fx is equal to F cos theta x. This is the logic where F is equal to the resultant force of these three. So for F force there are three components, Fx, Fy, Fz. These three are called as components. 3D means three components. This is called as resultant. That's it. So what is the components? Fx is equal to F cos theta x, Fy is equal to F cos theta y, Fz is equal to F cos theta z. This is the formula to find out the unknown components. Okay. Now the magnitude. If you want to find out the magnitude by using the components, this is the formula. F is equal to square root of x component square, y component square, Z component square. That's it. This is one of the formula. Next, we'll move to the angle. How to find out the unknown angle? We know the equation fx is equal to f cos theta x. Now put cos theta x here. Your fx will be f. Now you only need theta x. Take cos to the right hand side, then it will be cos inverse of fx by f. Cos inverse of fx by f. That is, apply the same to the theta y, theta z. Then cos inverse of fx by f, cos inverse of fy by f, cos inverse of fz by f. Easy. Now these are the values, these are the formulas to find out theta x, theta y, theta z. Now vector notation. In the space concept, we go for vector notation. A three-dimensional force, how a three-dimensional force represented in a vector form. See, f bar is equal to fx I cap plus fy j cap plus fz k cap, means unit vector. Okay, so f is equal to fx x component into I cap, y component into j cap, z component into k cap. That's it. It is a vector notation of a force. That's it. Vector notation of the force. Now, if I do a problems on this, then you get a complete idea. Okay, I will explain the problem. A force 100 newtons makes an angle 30 degrees, 60 degrees, 105 degrees with xyz axis respectively. Whenever he gives three angles, it means the concept belongs to 3D. Concept belongs to 3D. The concept belongs to space. Concept belongs to space. So find the components of the force 100 newtons. Now we need to find out the components of 100 newtons. So he has given the force value, he has given the values. We need to find out the components. Given data f is equal to 100, theta x, theta y, theta z. Okay. So we know that from the above formula we can write. If you don't know the formula, no worry. We have to remember these components. Fx is equal to f cos theta x. So your theta x will be the cos inverse of fx by f. So in the concept, he has given f value, he has given theta x value. If you substitute 100 into cos 30, your x component will be 86.6 newtons. Now come to fy. He has given fy theta y 100 cos 60, 50 newtons. Fz, he has given f value and theta z value. Apply minus 25 newtons. So you got three answers. I mean, you got three components. Fx is equal to 86.6, fy is equal to 50, fz is equal to minus 25. Now substitute all these components in a vector form. You will get f bar is equal to 86.6i plus 50j minus 25k. Very good. Now we'll move to the second problem. Compute the magnitude of force F whose components along x, y, z directions are 12 kilonewtons, 24 kilonewtons, 36 kilonewtons respectively. Now in this problem he has given the components directly. He has given fx, fy, fz. He wants us to find out the value of f, and we find out the inclinations also. Inclination is nothing but theta x, theta y, theta z. In this problem we have to follow this. We have to find out the values. I will tell you, no problem. So f bar is equal to, we know that vector notation. He has given this 12 minus 24 minus 36. Now we know how to find out the magnitude of the resultant in the 3D. What we have to do? Square root of fx square plus fy square plus fz square. Substitute all the values. You will get f value 44.89 kilonewtons. So by the components you have find out the resultant. In the previous problem, by the resultant you have find out the components. That is the difference. In some problems he will give components. You need to find out the resultant. In some problems he will give resultant. By that you have to find out the components. That's it. So we know that. We know this formula. Theta x is equal to cos inverse of fx by f. We know fx, we know f. We know fy, we know f. We know fz. So similarly what happens? Theta x is equal to 74.49, theta y is equal to 122.31, theta z is equal to 143.31. Clear? So we got three dimensions, I mean three angles, three inclinations. Along with that we have find out the value of the force also. In the first question he has given force and he has asked to find out the components. In the second problem he has given the components and he asked to find out the resultant of the forces, and along with that we need to find out the inclination of the components with respect to force. Okay, I hope you understand this.